Hello students, Dr. Bhavani Regmi here. In today's lecture, we are starting chapter 7. We will be talking about the gases mostly in this chapter. You know that gases are one of the states of matter, right? Others are solids and liquids. Before diving into the behavior of gases and the gas laws that govern the properties of gases, let us have a slight background here. Okay, so we will see that we have already learned, or the basic knowledge that we have for three different states of matter, right? They are solid, right? Let me go back. They are solids, liquid, and gases, right? At fundamental level, we have understood that in the case of gases, the particles are much smaller and they are far apart from each other, right? In the case of liquid, these individual particles are much closer to each other, so they do have a very little freedom of motion. It means we can pour them, they can flow from one place to another, but they cannot move randomly, right? They cannot run around, expand around randomly. Similarly, in the case of solids, the particles are much closer to each other. Okay, the atoms, or they could be molecules, these will be much closer to each other. As a result, the structure of solid is rigid, right? The volume of the solid is fixed, right? The gases, since they can randomly move around, the volume of gases depends on what is the volume of the container that is containing the gases, right? The gas molecules will just expand and flourish, right? Flow, and it will take the space that is available, means the volume, right? So the basic fundamental difference on the three states of matter can be explained on the key, right? The distance between the particles. If it is much larger, right, the space between the two particles, we do have gases. If the distance between the particles are much closer, then it is liquid. If they are very fixed, the position of the particles are fixed and they cannot move from their room, they cannot move from their position, then we have solid state. Okay, so that is the basic difference between them, and due to these differences in their molecular label, we will see different properties, right? The gases have different properties than liquids, than solids. So let's explore about these properties in our chapter. So basically, the properties of gases was first given by a theory, we call it kinetic molecular theory. So we are going to learn the different assumptions, okay, or the postulates of this theory. What does this theory tell us about the behavior of gases? Let's explore that. It says gas consists of particles that move randomly and rapidly. Right? We just learned that gas molecules will move randomly and in a chaotic fashion, right? Very fast. And then the size of the gas particles are small compared to the space between the particles, right? Because the gas particles are much farther from each other, right? The space between them is much larger, right? Compared to that vacuum, or let's say compared to that space between them, the particles themselves are much smaller. Okay, so that is one of the property of gas. The gas particles exert no attractive forces on one another. Okay, so this is one of the postulate of the kinetic molecular theory. Okay, it says, it assumes that there are no attractive forces. The reason is these gas particles are far from each other. Okay, and they also do not have any charges in them, right? We have learned in the class that if we have positive and negative charges, then there will be force of attraction between them, electrostatic force of attraction, right? In the case of gases, they are neutral atoms, so we do not have that kind of force of attraction. And also these charges or any atoms, they have to be close to each other, right? Distance wise, they have to be close to each other in order to have that interaction, in order to have that attraction. If they are in a distant relationship, right, if the atoms are too far away from each other, then there will be no attractive forces exerting between them. So that is what happening in the gaseous phase. Okay, the gas particle will exert no attractive forces on each other. The other property is related with the kinetic energy. Okay, if you remember, if you recall, you know that kinetic energy is the energy of motion, right? Potential energy is the energy due to the position, and the kinetic energy is energy due to the motion of particles. Whenever the particles are at motion, they are constantly moving, they possess kinetic energy in them, right? And so all the gas particles, as we mentioned in the first postulates, they are moving, right? They are randomly and rapidly moving. It means they do have kinetic energy in them. And whenever you increase the temperature, the kinetic energy will also increase. Okay, so that is one theory, postulate of this theory. So whenever we increase, okay, the kinetic energy will go up if you increase the temperature, right? We have learned about this in collision theory too. You increase the temperature, then the particles will move faster. When they move faster, they will possess the kinetic energy more in them, right? Because the kinetic energy is, after all, the virtue of the motion, right? Similarly, let's look on one more postulate. When the gas particles collide with each other, okay, since they are randomly moving around, there is a chance that they will collide with each other, right? Sometimes they will come closer and then collide. And when they collide, they will rebound and they will travel in the new direction, right? We have seen the billiard balls. If you hit the billiard balls with another ball, then that ball will move the direction, right? That will move to the new direction. That is what we also observed in the case of gas particles. And one important is all the gases, okay? The gases could be gases could be something like oxygen gas, right? Something that we need for the survival. For example, carbon dioxide gas, the gas that we exhale, right? And the plants take to make the glucose out of it, right? Either it be oxygen, carbon dioxide, or any other novel gases like helium, argon, or krypton, right? These are the novel gases of the periodic table. Whatever the gases are, okay, either they are the atom, the elemental form, or they are the compounds. The gases, all of these gases will have the same property we just talked about, and all of them, when they obey this property, they are obeying the ideal gas law, and we call them ideal gas. Okay, so we will explore what do we mean by ideal gas law in a minute. Now, I mentioned that the gases are constantly moving, right? So in the following section, you will be hearing a lot about pressure, volume, number of moles of gases, and temperature of gas. Okay, all these different function, they are used to explain the condition, the property of the gas, okay, the state of gas. If I have a container, right, a tank that is containing a gas, then in order to explain what gas is that, what is it, I have to talk about the pressure of the gas, the volume of the tank, and like the amount of gas in it, what temperature I'm measuring. All these different physical entities will be very helpful to work with. Okay, so what is a pressure? Let's go here. When the gas particles collide with the walls of container, okay, if I have a tank that has gas particles in it, right, the particles are constantly moving apart from each other, right, they are moving and they are hitting with each other, colliding, as well as these particles are colliding the walls of the container. Whenever these particles collide the wall of container, they exert certain force in them, right? And force in that particular unit area of the wall, okay, in physics, the force per unit area is called pressure. So the gas exert the pressure means the gas molecule hit the walls, collide the wall, and then it exert the pressure. Okay, we can measure how much is that pressure in different units. We can measure in atmosphere, mmHg, or torr, or psi, or pascal, depending on different areas we are working with. Okay, and you want to memorize this one, the relation of conversion 1 atm, actually 1 atmosphere, in short we call 1 atm, is equal to 760 mmHg. This one you want to memorize it. So in our everyday life, we measure gas pressure, the atmospheric gas pressure, by using barometer. Okay, so the instrument to measure the pressure of air is called barometer. Generally, the barometer has a long tube and it has a flat disc, and we use liquid mercury. Okay, liquid mercury. The mercury is the only one liquid non-metal. Okay, very heavy, silvery shining liquid. We pour that on a disc. Okay, and then we put the tube, invert it into that disc that has an opening on this end. Then what will happen? The air will pressurize, right? There will be air everywhere on the surface of Earth. The air will push the mercury, and some of the mercury will rise into the capillary, right, of the tube, and it will walk on the tube of the tube here. So how much is the height of the tube? Is, if we measure that in millimeter, it is 760 mm. Okay, 760 mm Hg, this height of mercury, when we observe that, we call it 1 atmosphere of pressure. Okay, so we are relating the height of mercury to tell that the pressure exerted by the atmospheric air. So similarly, we can convert 1 atmosphere is equal to 760 torr. Okay, 1 atmosphere will be equal to 14.7 psi, pounds per inch. Okay, and this is 1001,325 pascal. So the first one is important. Okay, so if we are given 1 unit, we can simply convert that into another unit, right? Just follow the unit conversion we learned from chapter 1, right? So now we want to learn the different gas laws, okay, to understand the behavior of gases. And as I mentioned, I will be talking over again and again the pressure, the volume, the temperature, right? You know, the temperature is the hotness or coldness of a body, right? Volume is the space occupied by the gas. P is the pressure, means the pressure exerted by the particles when they collide on the or hitting on the wall of container, right? So we learn about the relationship between these function on these laws. Okay, the very first one is known as Boyle's law. What does it say? Boyle's law states that for a fixed amount of gas at constant temperature, okay, so N is the fixed amount of gas, okay, when N is constant and temperature is constant, what will be the relation between pressure and volume? That is explained by Boyle's law. Okay, Boyle's law says that if we keep the number of moles of gas constant, if we keep the temperature constant, then pressure and volume of gas are inversely related with each other. Okay, it means that the volume will be inversely proportional to the pressure. In math, we write this way, okay, at constant N and temperature. What does it mean is, if you increase the volume, the pressure will decrease. Okay, I have opposite way. If you decrease the volume, the pressure will increase by the same factor. So if you increase the volume by 2 times, the pressure will drop by 2 times. That is the meaning of inversely related. Okay, when one goes up, the other goes down, and vice versa. So that is the relation we see in pressure volume of a gas. So I can write this as, if I have this mathematical relationship, I can write V is equal to, instead of that, so this sign is called proportionality. Okay, so in order to convert the sign proportionality into equal to, I have to multiply that by K, a constant, and then I have P from up here. So that is, so P times V, if I rearrange this equation, P times V is equal to K, a constant. Okay, the constant means it does not change. The number will remain intact. So every time you multiply the pressure with volume, you should get a product, a number that is constant. Okay, so with this example, with this, we come up with an expression P1 is equal to, P1V1 is equal to P2V2. How? Because we have PV equal constant. If you have something like initial state and it has a pressure P1 and volume V1, it will be, when you multiply, it will be equal to a constant, right? Or if you have some changes and it becomes now pressure P2, if the pressure changes to P2, the volume will also changes to V2, right? But the product of P2 and V2 will be constant. That is something we get from Boyle's law. Okay, so here you can see P1 V1 is equal to K and K is equal to P2 V2, means these two guys we can write equal, right? So P1 V1 is equal to P2 V2 whenever we have constant number of moles and constant temperature. Right? So this is the Boyle's law. Let's see that with this example here. Okay, I have here, if the volume of a cylinder is halved, the pressure of the gas inside the cylinder double, right? If you decrease by 2, it will the volume decrease by 2 means pressure will now increase by 2 times, right? So it will double. So if you have a cylinder that has a piston and now you have the gases inside the cylinder, let's say that they are hitting on the walls and the pressure exert is 1 atmosphere. When you measure the volume, it is 2 liter, right? Now, let's say you squeeze that. Okay, by pressing the piston down, you are making less space available for the gas molecules, right? You drop the volume from 2 to 1. Then now if you measure the pressure, it will be no longer 1 atmosphere, it will be 2 atmosphere. When volume decrease, the pressure increase, right? Because they are inversely related. You have here decrease the volume by 2 times, the factor of 2, so the pressure will increase by the factor of 2. Does that make sense? Okay, so that is Boyle's law. And we use Boyle's law every day. Okay, something that I already explained. So I'm going to show that where do we use Boyle's law in a while. Before going there, let's work on this math problem. Okay, you might get problems similar to this in your exams or mastering or homework, connect homework, okay, or quizzes. Let's read this question, dissect this question into what are given values and what are asked, and then we can work on that. Okay. So, if a 4-liter container of helium gas has a pressure of 10 atmosphere, what pressure does the gas exert if the volume is increased to 6 liter? Okay, all these questions that are related with gas laws, they will have a somewhat similar pattern. Okay, the pattern is the questions will talk about the initial condition, okay, and then it will talk about you will do some changes on them, okay, and there will be now the new values of pressure, volume, or temperature. Okay, so you will have these function initial state and the function at final state. So initial state function, we just put one subscript in them. For the final, we put two. Okay, so initial conditions and the final conditions. Now let's extract information. If a 4-liter container means your volume, right? It is a liter. Liter is measured, like volume is measured in liters. So I have a volume there. And this is initial condition. So let's say this is V1. Okay. 4-liter container of helium gas has a pressure of 10 atmosphere. Pressure is measured in unit atmosphere. So you have a pressure here. If it is V1, then corresponding pressure is P1, right? The initial condition. Now, what pressure does the gas exert if you are going to increase the volume to 6 liter? So you are making changes, and then your new condition, your volume 2, the final state is 6 liter. In that case, what will be the pressure? Means what will be your P2 value, right? That is the question is asking. So if you correctly understand, analyze the question, write down who is P1, P2, who is V1, V2, half of this task is done. Okay, rest you just have to plug in the values, the given ones, and solve for what is not known. So here we are all talking about P and V, right? P1, V1, P2, V2, and according to the Boyle's law, P1, V1 is equal to P2, V2, right? We saw this relationship in earlier slide. We want to memorize this or understand this. Okay, it may be provided, this formula may be provided in exam. Right now I forgot, I have no idea whether it will be there or not. Okay, but I will teach you how to remember that. Okay, we will be talking about more laws, and I will teach you, I will talk about it, how to remember. Okay, for now, P1 is 10 atmosphere, V1 is given, V2 is given. You have to solve for P2, right? So let's segregate this P2, rearrange this equation such that we have P2 in one side. You can bring P2 in one side if you divide this equation by P2. Sorry, you divide this equation by V2, right? Then you will get rid of V2, right? So your P2 will be now P1 V1 divided by V2, right? Or you can understand this. Let me go something that we call it rearrangement. You have these in the multiplication, right? Multiplication 1. When you bring this on the other side of the equation in order to segregate out the P2, the multiplication will become division here. So we have P1 V1 by V2, right? So this is just another way of telling that divide both sides by V2. Anyway, now plug the number. P1 is 10 atmosphere. Okay, V1 is your 4 liters and V2 is your 6 liter. Okay, in the question, if the units are not in the same base, then you have to convert. Okay, if one of them is ml, another is liter, then you have to bring them to the uniformly one unit. Okay, whatever it is, you have to do uniform so that they can cancel. So here liter and liter cancel out. You have 10 times 4 is 40. 40 divided by 6, that many pressure will be the answer. So let me do this in calculator. So I have 40, right, divide by 6, that is 6.67, and we have, let's go for the significant figures, how many to write. We have here 3 sig fig here, 2 sig fig here, 2 sig fig. So I have to write the answer in 2 sig fig. My calculator gives me 6.6666666666667. I have to write that in 2 sig fig. So I will write 6.7 atmosphere. Okay, so that is the new pressure of the gas when the volume is increased to 6 liter. Okay, so you just have to remember P1 V1 is equal to P2 V2. Here you have to find for P2, so you plug in other numbers and solve for it. Sometimes the question might ask you for V1 when others are given, or the question might ask you for the P1 when others are given. Okay, whichever is unknown, you have to separate that from rest of others and then solve for it. Okay, it is basic algebra, you have to use it. And now, as I mentioned, I want to show you the real application of Boyle's law. Where do we use it? Okay, we use Boyle's law whenever we are doing respiration process. Okay, so in inhalation means take in the air, right? What will happen is the diaphragm, a little bit biology here, the diaphragm will go into the rest position. Whenever the diaphragm goes to the rest position, you will have bigger volume of the lungs, right? So volume of the lungs is increased whenever the diaphragm goes to the rest position. Okay, if the volume increase, according to Boyle's law, the pressure of gas decreases, right? So within the lungs, the air pressure will go down. And compared here, the atmospheric pressure, there will be always one atmospheric pressure, right, on the surface of Earth. And then you have low pressure inside the lungs. You have one atmospheric pressure outside here. Then always the air will easily flow from high pressure to the low pressure. And then we easily breathe in the fresh air. Okay, so fresh air enters our system. When the volume goes up, the pressure goes down, and that helps the fresh air to go in. So the lung volume increases, causing the pressure in the lungs to decrease. As a result, the air flows in, and we do inhale. So that air goes in and rest of the biology function will occur. Okay, and then whenever we want to expel, right, exhale, take the air out from the lungs, now the diaphragm will go back. Okay, it will no more in the rest position, it will go up. That means now the lung, it will squeeze, and when the lung squeeze means now the volume decreases. The volume of lungs become small, it decreases. At this case, we have increase in the pressure. There will be more pressure inside the lungs than the outside atmospheric air. Again, the gas, the air flows easily, automatically from high pressure to the low pressure, right? So now the air is out. The air with the carbon dioxide, we exhale carbon dioxide, right, more in amount out of the body. So in this case, what is happening? During the exhalation, our lung volume decreases, our pressure in the lungs increases, and that's why the air flows out. So we learn about Boyle's law, right? The Boyle's law talk about the pressure and volume when the number of moles and the temperature is constant. Okay. Similarly, we will study the other laws that shows the relation between other variables, okay, other functions. So Charles' law, Gay-Lussac law, other laws we will be following in our next lecture video. Thank you.